Hello dear students, this is Dr. Niaz Muhammad. In this lecture, I shall discuss some important and basic points about elements. So let's take a start. An element is a pure form of matter consisting atoms of same atomic number. Let's consider this rectangle as a piece of matter. Now all the atoms present in this rectangular piece of matter shown by the symbol Na has same atomic number, that is 11. So this piece of matter consisting atoms of same atomic number represents an element, that is sodium. Now if we replace some of these atoms by other atoms of different atomic number, then we can't call this piece of matter as an element. Now this piece could be a compound or a mixture depending upon the type of interaction the sodium atoms develop with these different atoms. Remember, in an element, all atoms should have same atomic number. Their atomic masses may be different as elements usually exist in form of different isotopes. Consider the example of magnesium element. Here you see all atoms have same atomic number, that is 12. However, atomic masses are different, that is 24, 25 and 26. These three different atomic masses show three different isotopes of magnesium element. Now, some points about elements. 118 elements are known so far. Now, out of these 118 elements, 92 are naturally occurring, while remaining elements are synthetic and made in research labs by scientists. Each element is represented by a proper symbol. For example, sodium is represented by Na, magnesium is represented by Mg, and iron is represented by Fe. The most common elements found in air are nitrogen and oxygen. Nitrogen makes 78% of the air, while oxygen makes 21% of the air. Also, in the earth crust, the most common elements are oxygen, silicon, aluminium, iron, and calcium. These elements make almost 90% of the earth crust. Elements are present in all three states of matter. Most of the elements exist in solid state. For example, iron, carbon and calcium are solid elements. Mercury and bromine exist in liquid state at room temperature, while hydrogen, helium, nitrogen, oxygen, neon, fluorine, chlorine, argon, krypton, xenon and radon are gaseous elements. Elements may be made up of free atoms, ions, or homoatomic molecules. For example, the element helium exists in form of free atoms. The element hydrogen exists in form of diatomic molecules, while metals like sodium exist in form of positively charged ions surrounded by a negatively charged electronic cloud, as you can see over here. But remember, in any form, all atoms of an element have same atomic number. Now, some of the elements are called radioactive elements. These elements are unstable and show radioactive decay, means emit radiations or small particles from their nuclei and make relatively smaller and more stable elements. For example, uranium-238 having atomic number 92 shows radioactive decay and form thorium-234 having atomic number 90. During this radioactive decay process, an alpha particle is emitted. Remember, an alpha particle is the combination of two protons and two neutrons, so we can call it a helium nucleus. We know elements have protons and neutrons in their nuclei. When number of protons and neutrons in the nucleus are similar or same, then the element is stable. For example, the nucleus of helium has 2 protons and 2 neutrons. So helium is a stable element and show no radioactive decay. Similarly, nitrogen has 7 protons and 7 neutrons in its nucleus. So it is stable and show no radioactivity. Another example, carbon has 3 isotopes, that is carbon 12, carbon 13 and carbon 14. Carbon 12 has 6 protons and 6 neutrons, so it is stable and show no radioactivity. Also, carbon 13 has 6 protons and 7 neutrons. Still, it is stable and show no radioactivity. However, the carbon 14, which has 6 protons and 8 neutrons, show radioactivity. Another example, hydrogen has 3 isotopes, that is hydrogen 1, hydrogen 2 and hydrogen 3. Hydrogen 1 has 1 proton and no neutrons. Hydrogen 2 has 1 proton and 1 neutron in its nucleus. Both these isotopes of hydrogen are stable and show no radioactivity. However, the hydrogen 3 having 1 proton and 2 neutrons in the nucleus is radioactive. It means isotopes of elements having more neutrons are relatively unstable and can show radioactivity. In general, when neutron to proton ratio is greater than 1.5, then the element becomes radioactive. Let's consider the element uranium, represented by the symbol U. Its atomic number is 92. It has 3 important isotopes, that is uranium-234, uranium-235 and uranium-238. Uranium-234 has 142 neutrons with a neutron to proton ratio of 1.54. Similarly, uranium-235 has 143 neutrons with a neutron to proton ratio of 1.55. Also, uranium-238 has 146 neutrons with a neutron to proton ratio of 1.58. Now, as in all these 3 isotopes, the neutron to proton ratio is greater than 1.5. So these isotopes of uranium are radioactive. The radioactive isotopes of different elements have some important applications. For example, uranium-235 is used as a fuel in nuclear power stations to generate electricity. Cobalt-60 is used to destroy cancer cells. Also, iodine-131 is used for thyroid function tests and for treating thyroid cancer. Strontium-89 is used in bone cancer treatment. In addition to these applications, radioactive isotopes are also used for sterilization of medical equipments. Radioactive isotopes are also used for locating leaks in gas or oil pipes, and they are also used to check the thickness of metallic and plastic sheets. Now, let's move towards types of elements. All known elements can be classified into 3 different types, that is metals, nonmetals, and metalloids. Metals are the elements having 3 or less than 3 electrons in the last or valence shell, except hydrogen, helium, and boron. Hydrogen has 1 electron in the last shell. Helium has 2 electrons in the last shell, while boron has 3 electrons in the last shell. But still, these 3 elements are not considered as metals. Out of the total 118 elements, 91 elements are metals. Metals are electropositive elements. It means metals have the ability to lose electrons and form positive ions or cations. For example, a sodium atom loses 1 electron and form Na1 plus ion. Also, a magnesium atom can lose 2 electrons and form Mg2 plus ion, while an aluminium atom can lose 3 electrons to form Al3 plus ion. Metals are shiny solids except mercury that exists in liquid form at room temperature. Metals have positive ions arranged in form of layers. These positive ions are surrounded by a negative electronic cloud. The electrons are free to move. This free movement of electrons makes metals good conductor of heat and electricity. Also, if metals are hammered or stress is applied to them, the positive ions arranged in layers can roll over or slide. This property makes metals malleable and ductile. Malleable means metals can be drawn into sheets, and ductile means metals can be pulled into wires. Now, metals can be classified into two types, that is, main group metals and transition metals. Those metals which always lose fixed number of electrons are called main group metals. For example, a sodium atom always lose one electron and carry 1 plus charge. Also, a calcium atom always lose 2 electrons and carry 2 plus charge. Now, the second type of metals are called transition metals. Those metals which can lose variable number of electrons are called transition metals. For example, iron can lose 2 electrons and form Fe2 plus ion. Iron can also lose 3 electrons and form Fe3 plus ion. Similarly, copper can lose 1 or 2 electrons and form Cu1 plus or Cu2 plus ions. Transition metals are hard solids except mercury, which is liquid at room temperature. Transition metals have high densities. Transition metals usually form colored compounds. For example, the compounds of copper 2 ions are mostly blue or green in color. Another property of transition metal is that they can act as catalysts, means they can speed up chemical reactions. For example, hydrogen gas and nitrogen gas react very slowly to form ammonia gas. However, in the presence of iron catalyst, the reaction between hydrogen and nitrogen become quite fast. Now, the second type of elements are nonmetals. These are the elements having more than 3 electrons in the last or valence shell, except hydrogen, helium and boron. Hydrogen has 1 electron, helium has 2 electrons and boron has 3 electrons in the last shell, but still these are nonmetals. Out of total 118 elements, 20 elements are nonmetals. Nonmetals are found in all 3 states. For example, carbon is a solid, bromine is a liquid, and oxygen is a gaseous element at room temperature. Solid nonmetals are brittle in nature, means they convert into pieces when hammered. Nonmetal can exist as free atoms, for example helium and neon. Nonmetals also exist as simple homoatomic molecules. For example, hydrogen gas exists as H2, oxygen gas exists as O2, phosphorus exists as P4, and sulfur exists in form of S8 molecules. Nonmetals can also exist in form of macromolecular structure in which large number of atoms are held together by strong covalent bonds. For example, carbon. Now, in all these forms, no free moving electrons are present, so nonmetals are bad conductor of electricity. Also, nonmetals are electronegative elements. It means nonmetals have the ability to gain electrons. For example, fluorine gains 1 electron and form F1 minus ion. Oxygen gains 2 electrons and form O2 minus ion. And nitrogen gains 3 electrons and form N3 minus ion. Remember, noble gases have complete last shells and have no tendency to gain electrons. Now let's discuss the third type of elements, that is metalloids. Metalloids show properties of both metals and nonmetals. Metalloids are solid like metals. However, metalloids are not good conductor like metals and show very low electrical conductivity. Metalloids are brittle like non-metals. Very few elements are metalloids, for example, silicon, germanium and antimony, etc. Now all these elements including metals, nonmetals and metalloids are arranged properly in form of a table that is called the periodic table. In the next lecture, I shall discuss some basic points about periodic table of the elements. And now let's summarize this lecture quickly. An element is a pure form of matter consisting atoms of same atomic number. There are 118 elements known so far. 92 elements are natural while remaining are synthetic. Each element is represented by a symbol. Elements can exist as solid, liquid or gas at room temperature. Elements may be made up of free atoms, ions or homoatomic molecules. Elements having neutron to proton ratio greater than 1.5 are radioactive. Elements are of three types, that is metals, nonmetals and metalloids. Metals are solid elements except mercury. Metals are electropositive, shiny, malleable, ductile and good conductor of electricity. Metals are of two types, that is main group metals and transition metals. Non-metal exist in all three states of matter. Nonmetals are electronegative and bad conductor of electricity. Metalloids are the elements showing properties of both metals and non-metals. Now dear students, please pause the video and try to solve this small test. Okay, if you tick these options, then your answers are correct. And thank you so much guys for watching this lecture. See you next time with a new topic.